Hi there, so welcome back. In this one, I'm going to show you how to do a portfolio analysis with Pyfolio. So the first thing I'm going to do here is import Pyfolio as PF, and I'm going to import matplotlib as pyplot as PLT, and I'm going to import another library within Quantopia called empirical. Then the next thing I'm going to do is get some algorithmic returns. So I call that algorithms. I'm going to use the same algorithms that I've used previously. So if you remember, if you come back to the IDE, we had a leverage example, leverage example is really simple. It just says send half the portfolio to Amazon and half the portfolio to Shaw IBM, and we also had some setbacks leverage, which we'll hashtag out. But what I really want is just this simple algorithm, which is essentially just to go long on Amazon and short and IBM. So we're going to backtest this, let's say, for 2 years. So from January 2015 to January 2017. And then I'm going to run the full backtest in order to get the hash code for the backtest. So we grab it here from the URL after the forward slash. That's the backtest hashed. I'm going to copy and paste that. And here we can see we have pretty good returns because we essentially knew the future, we designed the algorithm. So we come back here and say the following. We're going to say BT is equal to get backtest, and I'm going to pass in that hash. And it's going to get the backtest for me, and then I'm going to grab some information that I'm going to be using for this. So we're going to say BT returns is equal to BT dot. If you look at all the things that we have here, one of them is called daily performance. And I'm going to go ahead and grab the returns off of that. So within that backtest, we have daily performance information, which if we come back here, we can see the daily positions and gains. So that's the information we're going to be grabbing in a data frame format. So we have our backtest returns, and also going to do a couple more things here. I'm going to create an object called backtest positions and set that to backtest.pyfolio positions, which is another attribute I'm going to be using. And I'm going to say BT transactions is equal to BT dot Pyfolio transactions. So we can always see that Quantopian has a lot of these things built in mind, which helps as part of the analysis. It's really good with the platform. So we'll be getting the backtest from whatever algorithms, and then we got the returns, we got the positions, and we got the transactions. And with these three key things, we could do a lot of plots with Pyfolio and returns. So in order to do a lot of these comparison plots, we're going to create a really simple algorithm. And I encourage just to copy and paste from the algorithm itself. I'm going to delete everything here, and I'm going to copy and paste the algorithm from my notes. Basically, the main idea here um, is I'm just going to set SPY as a security, and I'm going to set 100% of my portfolio to go SPY uh, at S&P 500. So it's going to eventually mimic the benchmark. So I'm going to run a backtest on this, the same time period. It's really important to be the same period as before. And as we notice here, the red line and the blue line are always the same thing. So basically, we just have a few losses because of slippage, but essentially it's the same way to get the stuff. So here we're going to grab the backtest again hash and come back here. And this one's for the benchmark. So we're going to say benchmark, and then I'm going to say the following benchmark returns is equal to get the backtest and hash that. And that's going to bring it in. And then we're going to do the following. We're going to say BM returns is equal to the benchmark. Uh, yeah, benchmarks, rates, dot, and the same thing as last time. We say daily performance, give me the returns. So essentially we're doing the same four steps like before. So we grab the returns, so we're going to say benchmark positions equals to benchmark rates, Pyfolio positions, and then we're going to say BM transactions is equal to benchmark underscore RETs dot Pyfolio underscore, and we want transactions. So we're going to run those two things, and now we have all the information we need in order to use Pyfolio. So let's go ahead and check it out. Uh, so there's also empirical that gives you a bunch of information. So you could also use empirical. So notice that it has a lot of alpha, beta, a lot of volatility. Um, so it allows quickly to grab information off a backtest option or some return. So for instance, so we look at the Sharpe ratio. We do shift tab here just to see what we have. So do returns, will bring back the Sharpe ratio. So for example, we could pass in our backtest returns, um, and it reports back that the Sharpe ratio for our leverage algorithm is 1.32. We could compare that with the Sharpe ratio with the benchmark itself. We could say empirical Sharpe ratio, and we say BM returns, and that brings out 0.47. So you can see there's a lot more volatility in the market itself compared to the euro trading scales. There's also a bunch of things to it. We could play around with this library a lot. So let's say we want to get the beta. Well, we can end up data. We could pass in the returns versus the benchmark returns. So it'll look something like this. You could say the backtrend returns versus the benchmark returns, and that'll bring in 0.060, which is the beta value. Okay, so we have this information. So let's go ahead and do some Pyfolio plots. Okay, so uh, the first thing we're going to do is the following. We're going to make sure that we don't call in by accident the benchmark returns by accident. So we're going to say benchmark is say BM returns just to make a difference. So let's start with cumulative returns and daily not cumulative returns. And these are quite easier with Pyfolio. So again, I'm just copy pasting from some notes here because a lot of this is just a standard code. So you can see I'm calling PF portfolio dot plot rolling, and then we're going to call PF Pyfolio, call PL. You can see all the different plots that are available to you. I won't show all of them, but I'll just show the most useful ones. But you can see, you could also call plotting dot, and you can see some other ones. So there's a ton of plots that are quite useful. So if I run this, you'll see a plot for cumulative returns and daily returns. So usually when I compare it to a back test, so you want to see our returns. So the back test returns, but this is, so that's the actual trading algorithm performing a lot better than the market. So also we could get the so that's one way of getting our returns. So we were able to do all of this in Panda. So I'm just going to go ahead and show you a couple of more from the notes, and we could see here three different plots. We have the annual returns on the backtest, the monthly return distribution, and the monthly return on heat map. So what does this mean? So we have three plots. We have annual returns. So we can see here what our returns on average for 2015. So we have now 60% returns, and we can see for 2016 actually we had negative returns. And now between those two is this dotted line right here. So that's annual returns. In this one, we can see the distribution on the monthly return. So you can see this histogram and the average marked by this dot there. And this black line is a 0% return. And these are the number of months that had that particular returns. And finally, over here on the right, we have a heat map where it tells you the actual monthly return as a percentage. So this allows you to quickly see what were the good months and what were the bad months. And we can quickly see our worst months were February 2016, and our best months were kind of the 7 months on 2015 and the 10th months on 2015. So that kind of shows you 2016 was done that great for us, but later on in 2015 we're much better on. So there's a bunch of other plots we could do to return the quantile. So we could run this, and this essentially gives you a box plot showing the distribution for the returns. Distribute for daily returns, for the weekly returns, and the monthly returns. And it makes sense that on a larger time frame, the distribution of returns goes wider. There's also a rolling beta plot. So again, just copy pasting from my notes here. So if I run this, I'll pass in the back-end returns versus the benchmark returns. And here we can see the 6 months and 12 months rolling beta. So you can see how beta changes depending on the market conditions. So then we have our average beta on that dotted line here. So that's another great plot to check out. We could also see a rolling Sharpe ratio. So I'll just pass that one in. And that passes on the backtest. And we were just telling us what is the Sharpe ratio over that period of time. So this is a rolling Sharpe ratio, and by default it says 6 months. But we could change that if you check it out. We could affect the window and change that time period. But here on the rolling 6 months Sharpe ratio, you can see the average on the blue dotted line, and that's 0. And there's a bunch of other factors we could draw, like drawdown. That's another great plot. And this one shows you the top 10 drawdown periods, and it kind of colors that for you, which is quite nice. What's nice about this is sometimes people like to do what is called an underwater plot, which is kind of like an inverse of what's going on here. So if we run this, it will show you the drawdown underwater plot. So here you can clearly see the actual percentage drawdowns as a factor of time. And here is just color for you and show you the difference between the peaks and the troughs. So we can also do things like plot the leverage. So with this one, we're also comparing it to the backtest returns compared to the backtest positions, and we'll show you the gross leverage throughout time. And there's also things like tear sheets that we could do. So that's another one. I'll just copy and paste that. So if you have a bunch of scripts in your algorithm, they'll show you things like what were top 10 long position of all time, top 10 short positions. All positions were held over the of the period, and you can see here in this case that would be we're always shorting IBM and always logging Apple. But for a more complex strategy, this would be very useful. And yeah, so if you're interested in another tear sheet, you could look at this one. And this one basically gives you a bunch of data frames with financial information. So it gives you the summary stats with all the trades, all the shorts, and all the longs. What time and percentage were the profit, how many winning trips, how many losing trips, how many times were evening, the total profit, gross profit. So a lot of useful information here. Return stats. If you keep scrolling down, it will show you this mapping plot. So two positions that are short and long. But there's more information on this on the documentation. So, but essentially, it'll just go blue when it's long and red when it's short. So in all this time periods, you can see that we're always short on IBM and always long on Amazon. But if you had a bunch of different securities, then you can see a more clear picture of which ones, what the positions were with all your different securities. And here you could also see the probability of making a profitable position, the better the algorithm. And also here it shows you the holding time and dates on and round trip returns and P&L per round trip. So a lot of useful information here. And that's basically what Pyfolio is there for, just to make your life easier. Before you had to do it manually in Pandas, but with Pyfolio it's got some great great plots, and there's more information on there if you check out uh, if you check it out. So okay, thank you.